Okay, guys, we're going to try to finish this up. They're doing some work and, of course, testing the PA system while the hour that I decide I'm going to take the lecture. So this equation right here was what we were finishing up in the last segment, square root of 2g times L minus L cosine theta. That's how you figure out the velocity if you are at the bottom of the swing, the equilibrium position. So now what we're going to do is try to fill in some place other than max and other than equilibrium. So somewhere in between. The example I gave you was if maximum theta was 15, what happens if we're at 10 degrees? Okay? So let's fill this in. If it's at some theta other than the maximum, the force is just mg sine theta prime. No big deal. Acceleration, g sine theta prime. Potential energy, mg times L minus L cosine theta prime. So all we're doing is we're changing theta to theta prime for these, okay? Kinetic energy is just going to be 1/2 mv prime squared, some other velocity, so I'm going to fill that in. And this is where it gets tricky. What happens if we want to figure out the actual velocity using potential energy and kinetic energy? So let's slide this up, and I'll show you how we're going to derive that. So the potential energy at maximum theta converts to some potential, so that'll be at theta prime, and some kinetic. Maximum is mg times L minus L cosine theta. Some of that will still be in potential, so mg times L minus L cosine theta prime, and some kinetic, 1/2 mv squared. Okay, so how do we solve that hot mess for v? Well, you have a mass in each expression, and you probably, hopefully, some of you will remember that mass is not important when we're talking about potential and kinetic energy. It's just based on height and how fast you're going. So now if we want to solve for v, I have to subtract this quantity from both sides. So I end up with g times L minus L cosine theta minus the quantity g times L minus L cosine theta prime, and that'll equal 1/2 v squared. So to solve for v, I'm going to multiply both sides by 2. And then take the square root. Okay? So if we put this back into our table, and I'm going to move this down so you can see it. To find the velocity at some angle other than maximum, it will equal the square root of 2 times the quantity g times L minus L cosine theta minus g, and you could factor that g out if you want to, times L minus L cosine theta prime bam. That's that. Okay? So you should be filling in this column right here to calculate force, acceleration, potential energy, and kinetic using this velocity. Now it looks like a big old hot mess, but it's really not too bad. It's just taking the potential energy at max and subtracting the potential energy at something other than max, and then solving for velocity. Okay, so that's all of the derivations. I'm going to be posting a worksheet for you with homework, and so if on Wednesday, we have a snow day again. I will expect that you'll use the lecture that's posted as well as the homework and try to wade through that together. I'll make sure that I post answers along with the worksheet so at least you know that you're getting to the right spot. So I hope to see you guys tomorrow on Wednesday. It's Tuesday at about 6 p.m. If not, you don't need me. You have the virtual version of me.